Okay, so starting off today, I'm going to pick my next joint to solve for. I'm going to come up here to joint E. So first we need a three-body diagram for joint E. Got this leg, which is CE. Got this leg, assuming it's in tension because we don't know what it is, this would be DE. And this leg down here, which we're going to call DE. We've also got a force downward applied at E, and that is going to be 500 pounds. We know what our magnitude is here for CE, negative 1,096. So DE and BE are the unknowns that we are trying to solve for in this one. Can't forget our angle. All right. I've got a couple of vectors. So what should I do now? What should I do if I have vectors? Yes, exactly. I should draw the component forces of those vectors. CE is the same leg that we already did when we did joint C. So it's going to have CE Y and CE X. If my memory serves, each of these had a value of 775. Sorry?
I believe so.
Yeah. So let's just jot those in there because we might need them again. Okay, BE also has got an X and a Y component. It's a vector. It's not an X, it's not a Y, it's a little bit of both. Call it BEX. All right, so I've got everything now broken down into forces that are either going perfectly horizontal or perfectly vertical. So I can start using my two formulas here. We've been starting with Y, so I'm going to continue going with Y. All right. So here's one of the tricky things. And this messed some people up. Of the ones that I looked through, this was a common mistake, and it's not really your fault. It's just something that we need to talk about. But FE is acting downward. I can pretty safely say that. But we're reading it here as a positive number, positive 500. CEY is another Y force that we know. It's acting upward. We're also reading it as a positive number. And then we have BEY, which is our only other Y force, and we're assuming it's acting downward. We think we know what it's doing, but we can't confirm that yet. We're going to assume it's going downward. But basically, we can't treat both of these things in our equation like positive numbers. Even though they both read as positive numbers, if we just add up this and this and this, what we're going to get is going to be incorrect. These two things are going in opposite directions. They need to show that mathematically. So when we sum up all the Y forces, I'm going to make this one. I'm going to make the 500 negative just because that's easier for me. It's going down. It seems to make sense when it's negative. So that means I'm adding the 775. BEY is going down also. So I'm going to treat it like a negative number also.
Which one are you solving for? Like what?
I am running this. And it's going to lead me to BE. And yesterday, our technique here was to take the component of the vector and rewrite it so that we're expressing it in terms of BE. And so if BEY is our opposite from the angle, then it's going to be equal to sine of the angle times BE. This expression right here in the parentheses is equivalent to saying BEY. So since it's BE we're looking for anyway, I'm going to substitute BEY in our equation for this expression. Anybody unsure why I just did that? Now I can start solving things. All I did here is I just rearranged this so that I don't have so many negative numbers. I'm also going to simplify this, and it should be reading negative 275 plus sine of 56 times BE.
So how did you go from the 500 minus 775 plus sine 56 with YBE to 0?
This is sine 56 times BE.
Oh, I thought that was a Y. So how did you go to the bottom one?
I added 500 to both sides of the equation. I subtracted 775 from both sides of the equation. I added sine of 56 times BE to both sides. And then I just simplified these here. So what I was left with when I added these together was negative 275 plus sine of 56 times BE. So I just subtracted this from both sides. I never even really had to move this over in the first place, so I just kind of did a redundant step. But I put the negative sine of 56 times BE back over to this side, so that's set equal to the negative 275. Now if I divide both sides by that negative sine of 56, then my expression looks like this. Can we solve for BE? Yes, we can. What do you get?
A positive number.
Well, that's good.
We got 527.27.
527.27. Anybody else get there?
This package is confusing. That is really different than a package. This is just
Oh.
331.71 is our correct answer. I'm trying to figure out how you guys got something else.
How do we get it? Is that what you're trying to figure out?
Look. Think of the negatives.
Do you want to see how I got it? You know why? Because Brittany's is not in degree mode. That makes a major difference.
That might make a difference. All right. We should get right about 331.71. As long as somebody's getting that and their calculator's in degree mode.
Wait, what did you say?
Oh, it's in
Degree
degree
mode.
You're going to have
Alright.
31.71.
Okay, that's what it
All right, beautiful. I was gonna say, please tell me I'm not the only one. So we got a value for BE, 331.71. Okay. So I'm gonna update this diagram to 331.71. All right. So this is where I got really confused with this problem, was trying to figure out when you're doing this summation here, how do you know what to call a positive and what to call a negative? Because it makes a big difference. When you're trying to add things up and set it equal to 0, and you basically just have to realize that if you know that two things are going in opposite directions, you have to treat them that way mathematically. Now we could have done this the opposite from how we did and still arrive at the same answer. We could have called the 500 a positive. We could have called the 775 a negative, and then because this is going down and we're calling it positive, we would have called BEY a positive as well. We could have run the equation like that, and we would still have arrived at positive 331.71. So whatever you had decided to do with this, whether you made the 500 a positive number or a negative number in the equation, as long as you made this number the opposite of that because they're counteracting each other, and as long as you made this downward acting force agree with that one, we would still arrive at the same conclusion. That make sense? Anybody like what? A little bit? All right. I'll show you on the sum of the x's because we run into the same thing. Purple marker's dying on me. I'm going orange.
I think sounds more cheerful.
Okay. So I summed up all the forces in the y direction, set them equal to 0, and I solved for my one unknown, which led me to a value for BE. And the only other thing I'm trying to solve for while I'm here at joint E is DE, an x direction force. How many x direction forces have I got?
Should we count the one below the DEF?
Yes.
Okay, so 1, 2, 3.
3. Anybody who says 4?
1, 2, 3.
Chris, 3.
Where's the third?
I heard a 4 somewhere.
Right below the D.
You got BEX, DE, and CEX. Now right now, we have all of our arrows pointing in the same direction. So we should just be able to add them all up. If we made one of them negative, we'd have to make all of them negative. We'd still arrive at the same answer, as long as they're in agreement as positive or negative numbers because they're going in the same direction. If I had DE going in that direction and I had CEX going in that direction, I'd have to make one of them positive and one of them negative because they're offsetting each other. But since they're both going in the same direction, I'm going to treat them both as positives or both as negatives. I don't like negative numbers, so I'm going to treat them both as positives. So CEX, 775, plus BEX, which again we're going to express it in terms of BE. So BEX can be equal to cosine of 56 times BE. Alright, so I've added up all of my x direction forces. I'm treating them all as positive numbers because all the arrows are going the same direction. BEX, we know this direction to be true because when we ran this, we got a positive number, so our assumed direction was correct. We know that that's supposed to be going that way. We know that CEX is supposed to be going that way. DE, we are assuming is going that way. So right now we're treating it like a positive number, assuming it's going that way. If the answer we get back is negative, we know our assumption was wrong. The magnitude will be correct, but the assumed direction will be wrong, that's all. So I know BE now. I can substitute that. We have 775 plus cosine of 56 times 331.71 plus DE equals 0. If we run this through our calculator, 331.71 times the cosine of 56, we should wind up with 185.27 plus DE equals negative 775. Yeah. For cosine of 56 times 331.71.
And yes, this is on the green road.
Yeah, I get the same thing you get. These answer keys are really bad.
Yeah, we figured that out.
Yeah. They do weird things with their rounding. Okay. So going to subtract this 185.49 from both sides. And I end up with a value for DE. You sure?
Nope, because I didn't put a negative.
Is it negative 960.49?
Yes, it is.
I don't even have a calculator.
Shut up, Chris.
Just mental mapping circles around the saw.
suck at math.
Yes, it's mental mapping.
The
All
one
right.
that
I got 960.49 as our value for DE.
Hey, negative.
Negative 960.
Yeah, it makes a difference.
Okay, it does make a difference. What difference?
That our assumption is incorrect.
Our assumed direction was incorrect. We weren't assuming the direction of this one. We weren't assuming the direction of this one. We were assuming the direction of this one, DE. So the value up here is negative 960.49. And we're going to turn around our arrows.
So that means it's in compression.
That means it's in compression. So far we have compression members all the way around this upper part. And these, main supports on the side. We have tension members down here at the bottom. We have a tension member here. And the only thing that we have not yet solved for
Is one that
is DB. Negative 960.49. We got one left. We got one
I
left.
bet you DB is going to be 331.71.
You think?
Yeah.
Is that a symmetrical truss?
No, Chris, teachers guess.
This world isn't perfect.
Because it's
It's
Not.
not.
If it adds any bit of suspense to the rest of this lesson, it's not that.
Assumptions, Chris, we can ask something.
Oh yeah, because you Alright, just forget what I just said.
Oh, joint D.
Joint.
Joint D. So this is AD, which we've already solved for. It has a Y component and an X component, which we also figured out a while back. And if I remember correctly, they were both 975. But this one is going to be negative 1,378. There's an applied force at D, 1,000 pounds down. We have our unknown vector here, call it dB, and we have dE, which we just solved for. We know that it is negative 960.49. And now this vector going down toward B, I need to give it its X and Y components. So we have dBx and dBy. Included angle here is 56 degrees. So your packet has you map this free body diagram out for every joint. It gives you a special little space to write this in. And when you're doing this free body diagram, you need to put in the direction of the arrows as long as you know them. And if you don't know them, then we are assuming their intention. You need to include any angles that are going to be relevant to solving this thing, and you're going to include any force values that you've already calculated or that you already know. this should start feeling a lot like a pattern by now. We're doing the same thing every time. We're running these two formulas. Every joint, we're running these two formulas. So we are going to start with our Y forces again. How many do I have?
1, 2, 3.
3. We have ADX. We have, or sorry, ADY, no mistake. We have 1,000 pounds applied at D. And we have our unknown here at dBy. Now remember, dBy is not our objective here. We don't care what the Y component of this is. We care what dB is. That's why we rewrite this thing in terms of dB. So we have dBy. It's going to be equal to the sine of 56 times dB. Since dB is what I want to solve for, I would prefer to use this piece right here than to say dBy. So, Y direction forces. Again, I'm going to treat the 1,000 as a negative number because it's acting down. That's just easier for me. I'm going to treat the 975 like a positive number because it is acting opposite of this. And if I'm calling this a negative, that means I have to call this a positive. And since this one's acting down, again, I'm going to call this one a negative. Negative sine of 56 times dB, all equal to 0. Plus 1,000 minus 975, and I have negative sine of 56 times dB equal to 25. Okay, dividing both sides by negative sine of 56.
It's a negative 30.16.
Negative 30.16
Yeah.
works for me. So we have a value for dB, negative 30.16. That one was fairly easy. Would have been a little bit messed up though had we gotten these pluses and minuses wrong in the first place. But again, if we did the exact inverse of this, positive 1,000, negative 975, and a positive sine of 56 times dB, we would have still ended up with a negative 30 at the end. Updating my free body diagram, that's about my last order of business here, 30.16. I've got a force value for every member of the truss. It's done. That's why I did this problem, to figure out what was the force being applied to every member of the truss, and we've got it. So now as an engineer, you can look at the force that's being applied at each strut and then sort of optimize that. We're actually going to be doing an activity with West Point Bridge Designer where you'll be competing against one another to make the cheapest bridge using the same specs, using the same parameters for the bridge. So you're all going to be spanning a distance that is the same length, but you're going to actually have to build your truss, and then you build and you test, you build and you test, you build and you test, and then if you notice that you've got certain structural members that aren't taking on a whole lot of force, like dB here, it only has to withstand 30, I don't know if these are, what are we, newtons or pounds? Yeah, pounds. only has to withstand 30 pounds of force. So you could take that one and you could make it out of a much skinnier piece of material. It saves money. It helps to know what these things are first, and West Point does a really good job of not making you do this. But the 2.1.7 activity does require you to do this method. And if you already gave that to me and I gave it back to you, you're welcome to turn it in again. Anybody is welcome to turn that in again, because so far from what I've seen, they're not really on target. Yes. And the second half of your trust building activity that we've been doing next door also asks you to do this. So it's not that bad once you have this pattern down. It just becomes a little bit of busy work. It's somewhat time consuming, but the math isn't that brutal. It's algebra. You're solving for an unknown. If you are still having trouble, if you're still really puzzled by this, the last 2 days worth of lessons are online. You're welcome to go on there and take a second look. You're welcome to come in and see me in your free time if you need me to explain something to you differently. But I definitely am not going to press on forward until I'm sure that we've got this for the most part.
We need more teachers like you.
Yeah.
Please, point this out right now.
Thank you.
Because like, we tried doing it this way and this didn't work, and I like how you changed it to do it that way so that we understood it.
I did it this way. Honestly, I did it straight from the
Well, like
packet.
you like explained it different so that